Job chapter 9, starting at verse 8. Which alone spreadeth out the heavens, and treadeth upon the waves of the sea, which make Arcturus, Orion, Pleiades, and the chambers of the south, which doeth great things, past finding out, wonders without number. 1 Corinthians chapter 15 says in verse 40, there are also celestial bodies and bodies terrestrial. The glory of the celestial is one, and the glory of the terrestrial is another. There's one glory of the sun, and another glory of the moon, and another glory of the stars. For one star differeth from another star in glory. May God bless the reading of His Word. Bible smack. All right, so today we are hitting New Year's Cosmology. Class number 8. Scaling the Mysterious Universe. Now today, we're kind of starting to deal with science and scientific evidence, but there is a fundamental misunderstanding of how we do science in today's 21st century, or at least it's been carried over from the 20th century. And that has been the issue of the place of mathematics. Mathematics should properly, if you had proper logic, it should be the cherry on top. It should be the finishings. And so when it comes to my cosmology, there will be a lot of math focused more towards the end than the current place. But instead we have mathematics as the start and the focus and the goal and the foundation instead of as the finishing touch. What should be the top foundation for science? And when we're talking about specific physical science, what should be that foundation? It should be observation and experimentation. That we would actually get the information. Because mathematics is what you do with the information after you receive it. But what happens when you don't have the information? What is 1 plus 1? Say it's 2. What is 1 plus 1 plus x? Say, well, it's 2 plus x. You have a mystery there that's not finished. So when we look around us and we look at the world around us and the things around us, we have to observe first before we get to making it logical through math. And what we do typically is we have gone on a gamble and we go with our mathematical equations first, and then we try things out. Now, the problem with that, and the problem with this gamble, is that even though we have greater technology now, why do we have greater technology? Well, because we had a foundation of absolute truth and revelation to where we could go and say, okay, we know that we have a world of order because we have a God of order. And then somehow we decided that we would get rid of that God and put man on the throne. But that doesn't provide us with the right foundation. And so even though we are a world with technology, we also are a world of mistakes. How many cars have broken down? How many times have we had glitches and errors with our computers? How many drugs have been mishandled? Think about how many people have died in our generation by illegal drugs, but even more troubling, by medical drugs. How many times have we said that we're going to do operation and then oops, it fails? You see, there is a gamble to this knowledge and a lack of certainty. When the doctor says we're going to perform surgery, it's more rare now that they say, oh, everything will be just absolutely fine. They might say that to get you to do it. But then at the end of the day, they're going to say, we don't know, we don't know, we don't know. And maybe some of you have gambled your family's life. And maybe some of you have hit that point where they didn't know and they did the wrong thing. You just say, well, we're not supposed to expect them to absolutely get it right. That's fine. But if we don't expect them to always get it right, then we might not be so faithful and devout when it comes to the observations that we just don't have. And that is why we are scaling the mysterious universe. What do we have to know that everything in the universe is exactly as they say it is? They say, well, we've got computer images. We made a drawing. Well, maybe, maybe not. Okay? There are paintings from history, but would you rather assume that somebody looks like the painting or they look like the photograph? You see, there are things that have less and less certainty, and we have to take that instead of going with this, oh, science is always right. Science can never lie to us. Science is what we have faith in. See, could be, could not be. An educated guess is still a guess. Now, the tools that we have used for gauging our universe goes beyond, at some point, what we see with our eyes, what we see in the sky, in the night sky. But what we have used is we have used math in the form of stellar parallax. Now, with the stellar parallax, we use a discipline called trigonometry. The one that has been our foundation point for astronomers is that we would take the Earth, and then we found out through the movement of shadows on a sundial. If you all remember the sundial, wherever the sun is, we cast a shadow, and that's how we would develop our clock. Well, by gauging the movements of the sundial, we were able to use trigonometry as far back as the ancient Greeks and determine the distance of our sun. I'm going to be using vague estimated numbers as opposed to like knowing every specific point, but the sun's about 93 million miles away. And that was figured out by the Greeks early on. So then, what did we do? Well, what we did is we took the distance of the Earth and the Sun, and assuming heliocentricity, we would say, okay, the Earth is always looking at the North Star. So we take, it doesn't matter if it's this one or this one, it doesn't matter what part of the year, we're always looking directly north at the North Star. So we take that in the distance there, and we triangulate. And that would give us our distance. I believe the distance was about, 300 light years? No, it was 421 light years. There's going to be two measurements that I'll talk about here. I believe that through trigonometry, I believe it was probably 300 light years. And so we get that number mathematically, and then we're able to start triangulating all the other points of space, all these other stars, we're able to triangulate and find the distances. And so that is the mathematics of stellar parallax. Then we used something called redshift or spectroscopy. And we basically, in my crude way of explaining this, we'd use radar and we would find all these stars and we would gauge something called the red shift. I explained this when we were going over the issue of the Big Bang Theory and debunking the Big Bang Theory. We called it Big Bang Busted. But all these stars, they have a red shift to them, and we would measure them according to that. Now, the big idea that I was going over is the fact that spectroscopy will measure all the greater limits to the universe. They would have to keep the stellar parallax limited. I believe it was limited to about 400 light years. And basically, the math would end up falling apart because the distance between these stars ends up being too small to calculate. The stellar parallax falls at a certain degree. But, as I said, the redshift that we learned from the spectroscopy is in contradiction. As we found out, I think it was in the late 90s to early 2000s, we found out that these two are in contradiction to each other by about 119 light years. So at that point, all the other mapping of the stars is off, and it gets off by bigger and bigger numbers. Of course, now we also have our famous telescope. The biggest telescope that we have, very famous, is called the Hubble Telescope. And it is a telescope out there in space. I know, I'm not trying to be an award-winning artist here. But basically, when we look at the Hubble Telescope, it is an eye like ours. Now, what you learn about a telescope is that you only have so much using the lens of your eyes to triangulate distance. And so there's a certain degree where it'll go out, and then after that it goes from the distance to 3 dimensions, and it becomes a 2-dimensional picture. When you go look out in space, at some point the wideness all comes together into 2 dimensions. This is the big philosophical problem with empirical philosophy, is that we really don't have a full understanding of space. Now, look at this shape that my hands are making. Okay, you see that? All right. Now, is that a triangle? Is it? You see, because we're not understanding space in that 2 dimensions that you're seeing there, we're losing our ability to be certain. And so, this has a limitation to it. Human eye, I'm going to give an estimation, which I think is a pretty good estimation. If you were on top of a giant mountain, perhaps you could see up to 20 miles away. But how far would you get until you hit the farthest distance you can get, and after that, you magnify? See, the Hubble Telescope, most of the Hubble Telescope is the idea of using magnification. So, 357.14 is a number that's specific to the Hubble, because what the Hubble can see is it can see 357.14 times what your eyes can see. Sounds good. And if you can see about 20 miles, then what are we dealing with? 7,000 miles maybe? Maybe 10,000 miles? Hold on. We're supposed to be looking at these stars that are umpteen billion and trillion light years away. See, we're not going with evidence, we're going with calculation. So there's a stopping point, and after that, what happens? Well, we're seeing something and we magnify it, and by magnify it, maybe we're seeing more, but maybe we're not. Maybe we are seeing something small get big instead of something far away come close. Do I have to do Grover? Near, far. I had to do that. Okay. So yeah, basically, we're hitting this place of uncertainty. The only thing we can really be certain is that if I travel, if I move to the place, if I measure, well, then I can know that much of what I've traveled across and what I've measured. But without doing that, my visibility has limitations, severe limitations. Well, have we been there? We have been to the moon. I know there's conspiracy theories out now, but, give them a shot, give NASA a shot. Been to the moon. And we've had satellites that have gone out to different parts of our solar system. One has just passed our solar system, where we've seen photos, for instance, recently of Pluto. And so we've got cameras that have been far, and we have had spaceships take us out to about where the moon is. But then when we start talking about the massive scale, I mean, there's nowhere even close. And the problem is, how do you know that you're going as fast as you think you're going, or that maybe you're going a shorter distance faster? You see, that all gets relative when there's nothing to measure it by. I usually have an illustration where I tell people about, imagine that you're in the desert. And I'll start using my great artistic skills again. Imagine that you're in the desert and you're on this road. And that road takes you all the way up, and then you see this horizon. Okay, let's say that's the sun. And basically, after you get to that horizon, you don't know. You're sitting down here chained up to the ground. And you got a big boulder or whatever, or a wife. And there's a rope. And two men come to tell you one says, that is 50 miles. The other guy says, no, that's 500 miles. Which one's right? You don't know. You just don't know. If you don't have anything to measure it by, then you can't really be sure. You lose certainty. It's called the fallacy of inductive logic. Now, when we're looking out in space, we have that 3D versus two-dimensional problem. We also have the problem of curved space. I am looking at something from the Earth, and let's say these stars are as many billion light years as they say. We typically think, okay, straight line to the star. But space has a curvature to it. And as we'll talk about in a later episode, the universe is spinning. Even Big Bang theorists agree with that. But if the universe is spinning, How do you know that it's that far away instead of being that far away? See, in other words, we are wrapped up in the curvature of space, and that star could be that close instead of that far. So even playing by the rules, there's problems. Then you also have to deal with the issue of reflection. I took a picture going down the street a couple years ago as I was writing out my first New Year's cosmology hypothesis paper. And by the way, I will link these at the bottom of the episode. But I was going down, and I saw the sun on one side, but then I looked over, I saw the sun on the other. Then I looked up again, and the sun was a cloud reflecting the sun. And so you had 2 points of light, but there was only one real one. It was reflected. What happens if the stars that we're looking at are actually reflections? Perhaps our universe is like a funhouse. Maybe we have that one star and all of these are just bouncing off reflections of that one star. Not that there's only one star of the universe, but what I'm telling you is that when we get into this issue of reflection, you lose certainty. Because remember, the only star we've seen is the sun. And you know, you can make the argument that maybe the sun's not even a star like those other stars. We have not been there. We've not been to the center of the sun. We've not been to the center of the earth. We've not been to the center of these stars. We've not been to another solar system. So much is utter conjecture. And then, let's see here. When we talk about the galaxies and the stars, our buddy the Hubble Telescope took a picture of deep black space. And I think it was the Herschel digital scale. I could be wrong, but I think it was that. But this is pretty famous, so people will pick up if I missed it. And the Hubble took a picture of deep black space. And then what they found was what they understood to be billions and billions of galaxies. Okay? Lots of these little lots of these little things floating in space. Now, my question is, knowing the limitation to the distance that you're guaranteed from a telescope to this magnification, if that was deep dark space, are we certain that these galaxies are truly the giant galaxies? Because they'll say it's like the Milky Way. Okay, that we're in the Milky Way galaxy, those are galaxies. Or are they truly galaxies? Or could they be microscopic? Could it be cosmic radiation, cosmic dust, different types of microscopic matter that have now been magnified? How do we really know? And at this point, I can't give you a specific mathematical principle to prove the exact size of the universe. I do know that the size of the universe keeps on expanding, because that is the philosophy of their mathematics that they're trying to show us. They want a universe that keeps on getting bigger and that keeps on expanding. And we'll talk about that, the expanding universe and other things about that nature. But what can we truly know? What are you really certain of? Now, I did look around on the net, and sometimes they'll have these ask a question to a physicist things, and I looked up one, I asked the question, I was like, how do we know that galaxies aren't microscopic? And the answer back was that, well, galaxies that are microscopic wouldn't have enough gravity. But atoms and molecules operate on something totally different: electromagnetic energy. And there is a group of scientists who have a different philosophy. They call it plasma physics. And another very close group, maybe the same in some instances, maybe not, but basically these guys, they call themselves an electric universe. They argue for an electromagnetic universe. And they've noticed that some of these galaxies here are doing patterns that you would find in currents of electrical energy. That begs the question, could these be something different than our interpretation of stars and galaxies? We have to deal with the mystery, and how can you scale this mysterious universe? The Milky Way. You say, well, we've seen the Milky Way, right? Here's the Earth, and here's this big Milky Way. About 100 years ago, a lot of people would assume that the universe was that Milky Way. Now they don't. I am more sympathetic to that old view that maybe the Milky Way is the universe. And when we look at it, have you seen a photograph of the Milky Way? No. Because we're in the Milky Way. Nobody's been outside the solar system, so nobody's been outside the Milky Way. And there's been a big debate among some of these astrophysicists. Is the Milky Way with 2 arms, or is it 4 arms? Well, how do you know? So if we don't know what the Milky Way is looking like, how do we know what other galaxies are looking like? And so we have that problem of scaling. And I think, I'm probably wrapping up with the topic today, but you do have to understand not only what you do know, but you have to understand what you do not know. I don't know if the universe is bigger or smaller. I assume. Okay? I assume it's smaller than what the Big Bang is saying. Of course, Big Bang say it's constantly growing, so I have to assume it's smaller than that, okay, because I don't think it's growing. But I make assumptions. I'd like to assume, okay, and this would be not my hypothesis, this would be my speculation, okay? And my speculation would be that perhaps the universe is just a little bit bigger, but not much more than the Milky Way. But once again, this is a mysterious universe. And the only one who's going to really know and have the inside track on it is God. We'll see you at the next class.